Perfect. Okay, so myself and Darryl, we're just going to present to you today the ORV3 Meta Frame project update. So I'm Stephen Moore, kind of introduced myself earlier, but I'm working for Rittal as the global account manager, but recently the project Rack and Power co-lead along with Ted.
Yep, I'm Darryl Daniel, mechanical engineer with Meta, primarily working on the Rack and Power team and taking part in a lot of the blind mate liquid cooling subgroup in the cooling environments.
So just wanted to cover the high-level status of the project for the ORV3 Meta Rack. It's kind of been a very long project. We've been working on it for the last almost 3 years at this point. So EVT isn't shown there, but that was kind of in the past between April 2021 and October. But one of the things we did do is we ordered long lead time tooling ahead of time during DVT to help accelerate a very aggressive PVT schedule for MP towards the end of this year. So we're just entering that now, which is good. So it's the end is in sight, which is great. Just a note here, the testing was completed every phase of the project. So I'll go into a little bit more details in the later slides, but DVT was where we got a pass on all the testing, which was great. And then PVT, which we're doing literally as we speak, just kind of closing things up and buttoning things up before we enter mass production. So now I'm just going to run through some of the design updates that we've done recently. There's been a lot of these presentations that myself and Darryl have done, so I didn't want to necessarily go over some of the previous updates, so just mainly the new updates that we've done recently. So here we've got the side seals that are used for airflow containment. Originally there was two diagonally across from each other on the frame, as you can see highlighted in red. We've added a third seal. So this is actually to allow when these racks are bayed in a data center, if they're not bayed rack to rack, where you have the diagonal airflow block, sometimes they're bayed next to a containment panel. And when they're bayed next to that containment panel, they need this additional seal to make sure that you get the airflow block that you need. So this was one of the most recent updates we did on the rack. So another update we did, we've added an additional label. This label is actually an OU and RU printed label, so it kind of shows you the shelf positions throughout the rack. So we have one of these in the front of the rack on the cable manager so that you can see that from the front and know exactly where your configuration is and where things are. But one thing that we actually found when we were trialing this, when assembling the IT shelves, so specifically the rails that hold the equipment, almost just because of the angle that you look down a rack when you're installing this into the rack and the toolless design, it's actually quite difficult to see if the shelf is level or not. So we were finding in assembly, you would assemble in the shelf and you'd kind of step away and then the whole rail would be at an angle, which obviously would be a problem for integration. So the way that we've tried to solve this is by adding in this additional OU tape in the center mid-rail of the rack. You can actually see along the eye line of where the position of that rail will sit when you assemble it. So this was the purpose, and so far it seems to have solved that issue. Another update that we did was around the bolt down for the rack. So the hole originally was on review during trials. We realized it was actually quite small, and at times if you were to drop the nut or bolt when you're bolting it to the pallet, it would take a lot of time and it would be quite fiddly. So what we've done is we've opened up the hole to a much larger dimension, and it's much more user-friendly. And there's also an additional benefit here with seismic bolt down, which is also being looked into separately as an accessory. This also helps with that as well. So an additional update we did here is on the inner weld baffle, which, as you can see in the exploded view, actually gets welded into the top of the frame in the canopy. The primary reason for this baffle is obviously airflow to prevent the hot oil exchange over the top of the rack. And what we've done here is we've actually extended the depth of that to give it a tighter fit to the equipment to ensure airflow blocking. And we've also added a 45-degree fold, as you can see at the very end of the baffle, to prevent any kind of catch point where the equipment's sliding in, and also it will help with health and safety as well if anyone's fingers were somehow in that area. So Another update we did, this is actually quite hard to show in an image, but what you can see there is there's a stiffener plate which goes into the bottom of the frame. This actually gets assembled in with the casters into the base tray, and it's there primarily to help pass the testing with the heavy loads that we're seeing in testing. One of the things, this is actually used to assemble the cooling manifolds into, so it actually goes through some holes in the base tray and into this stiffening plate. And one of the problems we were finding is the alignment of the hole for the fixing point. And so what we did is we created a pokey yoke feature for the casters and the actual fixing screws through to the base tray, which now drives the dimension of the stiffening plate and makes sure that that's all to tolerance and allows the cooling manifold to be assembled with no issues. So here's just a summary. It's a bit difficult to see, but of the DVT testing. So there's a lot of testing involved in the ORV3 rack, mainly based on the ASTM standards. There are some additional tests on top of that, but some of the harder tests are kind of your side and front impacts, rotational edges, and obviously the shock and vibration that we typically do. So one thing which I'll go into in a minute, we didn't only do this for the rack. We had to do it for each beam position. So within the rack, we now have a customizable stiffening beam position within the rack. It can either be plus or minus 7 OU in the up or down direction. And so we had to test the worst case positions, not only in the middle, but also upper and lower. So here, I'm just going to see if this video works. It's a video of the front impact of the rack. So that is one of the more difficult tests that we had to pass with the ORV3 rack. Because of the toolless design of the shelves that go, the equipment that goes into the rack, obviously there's the risk of delatching, which is obviously a big concern during transport. And so this was one of the most challenging tests that we had to pass. So this configuration here that you can see is the 1,600 kilo payload, and this was the middle beam position. And so we passed that, which was great. So.
Yeah, I think it's worth noting that we've talked about this before, but when we ship our racks from our integration sites to our data centers, they're fully configured with all the IT gear and cabling that they're going to have, and so making sure we test to that maximum payload in the created version was kind of the goal of this test.
Yeah, thanks for adding that context, actually. So yeah, as you can see, it's ship loadable packaging there. We also do testing on non-ship loadable, so the empty rack, but that's not kind of covered in this report. But this is the tests that obviously are much more difficult to pass. Okay, here's just another image of one of the other tests that we do at our facility in the UK within Rittal. It's actually here is a rotational edge drop where it's kind of raised on one side and when it's released it will drop and rotate. So in this image it was the beam down position. So this is where the stiffening beam in the middle is at the lowest position. With 1,600 kilos it managed to pass all of the tests that I summarized in the table earlier. So that was good news on that position. And here, this is a rotational flat, so the difference is it's in test, it's not raised on one side. It's a bit easier to pass than the test that you've seen on the previous slide. But what this is also showing is the beam up position. So where the beam up position, we actually found we had problems passing the front impact testing of the beam up position. So we actually did have to reduce the payload down to 1,400 kilos to be able to pass that, and hence why that's the overall rating for the Meta ORV3 rack now. The final set of testing we also did is no beam. So if you want a very flexible configuration that doesn't have any beam position in there, we also did testing on that. Obviously, without having that beam in the middle to really hold the rack stiff, you have to have a much lighter payload of 1,800 kilos. So there's the option there if someone wanted to have a more flexible configuration, but they are limited on how much weight they can actually put in the rack with that design. And as we're approaching mass production now, I just wanted to show you some images of kind of what we have set up in our facility ready to enter mass production. One of the things that we kind of ordered ahead of time, and as I mentioned earlier on early investments during DVT, was the weld fixtures. So this is obviously designed to hold all of the tight tolerances that we see within the frame. And it's also designed for easy ejection of the frame and also input of the components as well to optimize welding during during mass production. Here, I just wanted to show you some of the hard tool components that are also in the rack. First, we have the buzz bar. So this is it's basically the components within the buzz bar that are hard tooled. We have obviously the copper extrusions would have its own tool. The aluminium extrusions that are used as grounding on the left, and you can see at the top and bottom on the outside of the cage there in the image. And also the buzz bar cage itself is a perforated buzz bar, which needs its own tool as well. So lots of tools involved in that part. We also have the cable grommet there, which is protects the power cables going into the top of the rack and not damaging the cable against the sheet metal. But that has its own injection mold tool. A lot of FEA analysis was done by our design team in Rittal in the UK, not only on the force engagement of the clips when they enter the rack to make sure that it's easy enough to assemble, but also FEA on the flow of the material in the tool as well to make sure that going forward would be a quality part. And then finally, another tool part would be the IT rails along with the assembled spring clip, which goes in that rail. So both of those parts are hard tooled, obviously for cost effectiveness, and at mass production volumes, you're going to see a lot of these shelves. So this will help keep up with that volume. And then finally, just some rack images of the rack that in its final form entering mass production soon, and it also is under PVT testing right now. There is one of these racks on the Rittal booth out in the expo hall, and you may see this at other suppliers' booths as well. So yeah, just an image of that there.
All right, thanks, Stephen.
No problem.
So Stephen's kind of covered a lot of the validation testing that's happened up to this point. And like you mentioned, that happens at every MPI phase of the project, really to ensure we have a really robust and rugged design when we roll out into mass production. So as we approach mass production, Stephen kind of showed a schedule of where we're at. Tentatively in Q4, we're going to enter mass production. And so with that comes a lot of logistics and support that needs to roll out to support those racks as they start to enter our data centers. So throughout the program, while the main rack has been developed, there's also a bunch of different accessory kits and FRUs that have been developed to go along with that. And that's really to support that production as we scale up. So I'm going to walk through some of those. I'm not going to cover everything on this particular list. Items like casters and levelers, obviously, as we're moving racks around and shipping them, moving them throughout the data center, those are items that could be damaged, and so we do have FRUs created for those so that we can replace those in the field if needed. But I will go through a couple of these other ones in a little bit more detail, just to give you guys kind of an idea of what we're planning to support. So the first one is the side airflow containment panels. These would typically be used within our data centers on an end-of-row application. So with this particular kit, it's the same panel, can be used on the left or right side of the rack. They are removable, so they toe in at the bottom, screw in at the top. And then there may be some use cases, perhaps at a co-location site, where we need to restrict access to the rack, provide a little bit additional security measures. So we do have an option to add security locks to these panels if we need to restrict access to those. Another one, which is a modular design, and this isn't necessarily a FRU that's meant to be replaced in the field. We don't see this as being an item that's going to be damaged very frequently. But really what this was all about is for us, having maximum flexibility in how we configure our racks is very important. So really this serves two purposes. We've got these modular removable cable trays which screw into the front of the rack. And really what this is about is it's providing flexibility for us so it doesn't tie us to one particular cable management solution on the front of the rack. So for example, if we roll out another configuration in a few years, maybe we need to make changes, add additional features, we can easily create a new version of this cable manager tray, swap that in. In previous versions of the rack, so for example in V2, those cable trays were actually welded into the frame, so you didn't have that same level of flexibility. You kind of got what you got. And you had to create a completely new SKU for the rack if you wanted to make changes in that area. The second thing this does for us is, circularity and reuse is a big priority within Meta. And, as the first implementation of the rack comes to end of life, we can very easily change these out and reconfigure our racks and give them a second life. So this was part of it as well. So Stephen touched off on some of the testing where we actually did different configurations of the rack, and we moved that cross brace to different locations. So with our design, it's a plus or minus 50U position within the rack that you can actually move that cross brace around. We did testing, kind of all the extremes. And again, really what this is for is it gives us that flexibility I just described. When we're doing different configurations for our racks, we're not tied into one specific location. In the V2 racks, the cross brace was again welded into the frame, and so you didn't have that same level of flexibility. So really that's what this is about, is it's just giving us more options for how we put gear into our rack. Another accessory kit which will be ready as we roll into mass production is the stabilizer kit for the racks. So obviously we've got a lot of gear in these racks. They're extremely heavy when they're fully configured and loaded. In certain configurations of the rack, depending on the type of gear and where we put it in the rack, the center of gravity could be higher than what's acceptable from safety limits as we're pushing the rack around throughout the data halls or at our integration sites. So we have a toolless stabilizer kit which can be added to either side of the rack just to increase that overall footprint and provide a more stable base for the rack as we're moving it around. So this is toolless installation and removal. And again, it's not necessarily needed for every configuration of the rack or even for the empty rack as we move it around. But again, depending on how and when we put that gear in there, we may want to use these. And so these would be available both at our integration sites and our data centers to be used as needed. And I should mention, I guess, before the configured rack actually rolls out into production, it would be determined whether or not these stabilizers would be used through validation testing of that fully configured rack. And then there would be an indication on the rack itself indicating to the users whether or not they need to use these stabilizers. So if anyone here attended some of the liquid cooling tracks, you know that was a large focus for ORV3 was enabling the rack itself for liquid cooling to support some of these future applications. So what this is a liquid cooling bracket kit which enables us to convert a standard ORV3 rack into a liquid cooling enabled rack. It's a bolt-on kit, so all these components screw into different areas on the rack. There are some frame stiffeners, web stiffeners, which get added to the front area. And then there are 3 interface brackets, and those are specifically for positioning and providing tolerance constraints for the manifolds as they mount to the rear. And this is the blind mate manifolds that I'm talking about. So you take this kit, you mount it to a standard rack, and you end up with a liquid-cooled rack. Another option that we've developed is front and rear security door kits, and these are perforated doors. In the front, it's a large single perforated door. In the rear, it's a split door design. So why would we need these? Well, I mentioned earlier with the side panels, one potential use case is if we're installing some of our racks into a co-location site, maybe we need additional security at that location and we need to prevent access to the rack. So in these, we have optional security locks we can put on these doors, mount them to the front and the rear along with those side panels that I showed earlier. And now we have a fully contained rack which is locked on all sides so that users can't get into it. So there was a question earlier about seismic within the base specification as it's not currently specified, but we are developing a seismic kit for the meta version of the rack to be used really in specific locations that may require it. So this is not something we would put on every rack or really the majority of our racks. And there's a couple of different ways to implement this, but in this particular concept, we've developed a bracket kit which will ultimately support GR63 core Zone 2 seismic locations. It's a series of shear plates that get mounted to the rear of the rack, and then there's a L bracket that mounts to the floor as well. So there's been a lot of dynamic FEA analysis that the Rittal team has done really to optimize the stiffness of the frame and to minimize the displacements to where they're within acceptable thresholds. Same thing with the stresses as well. And so like I said, these all get mounted to the rear of the rack behind the gear, which obviously From a servicing standpoint, if you have to replace fan frees or something like that, that needs to be considered with these. These are screwed onto the back of the rack, so they would need to be removed individually to access some of that IT gear from the rear. All right, before we go, I did want to mention, as part of the sort of openness of sharing, the CAD for this particular design, at least a section of that CAD has been uploaded to the OCP website. So this is available now. It's a 3D CAD model, which includes the IT gear rails, both for the standard IT gear and the power shelves. It includes the cable managers at the front, the 48-volt bus bar, and then a movable horizontal support brace. So as Steve and Lauren mentioned in the spec overview, there's two versions of the design that are included in that spec. There's option 1 and option 2. This is the option 1 version, which has the bus bar in the middle, which is the version that Meta's currently working on. And then same thing, Steve and Lauren already covered this, so I won't spend much time on it, but there's an updated version of the base frame specification on the OCP website. So for those who are interested, you can go in and grab that. It includes the different tolerances on the rack, the interfaces for the IT gear, bus bar, things like that. It's all included. The plan views are part of the spec and can be downloaded and reviewed as needed. So this is not just to be clear, this is not the Meta spec for the frame. This is the actual OCP base frame specification that's on there. I think we do have a few minutes maybe for questions. If there's anyone that has questions on the design, we'll take a couple. Invite you to come up to the mic.
Hi, I'm Steve Webster. I work for Google. I'm curious if you could tell us a little bit more about how you move and unpack fully populated racks. You know, is the equipment fully seated and connected to the bus bar in shipment, or is it, you know, are they somehow offset? And do you have a kit, or is there going to be a kit for that sort of shipping?
Yeah, so for our configurations, the IT gear is mated to the bus bar, and we've done quite a bit of validation testing by taking contact resistance measurements along the bus bar pre-shipping and post-shipping, actually through the whole shock and vibe testing as well as transportation tests, just to verify we're not getting any sort of fretting on the connectors or on the bus bar itself during that movement of the rack from point A to point B. So there's been a lot of testing to validate that design. It's something that we've done on previous versions of the rack as well, where we fully configure our gear, everything's plugged in, send it off. So obviously packaging is a big part of that, right? So our racks are for V3 at least right now, it's going to be shipped in a full crate design, which allows it to pass some of those impact tests that Stephen went over earlier. We are working on other versions of packaging which may not require a full crate for shipping. Obviously, it'll have to pass those same stringent tests that we're doing with the crated version as well. But yeah, and part of that is the floating connector design, obviously, in the IT gear. You know, the idea with that is that you're not getting a lot of relative movement between the connector and the bus bar. So hopefully that fretting doesn't occur there. And like I said, we've done a lot of testing to validate that that's not happening.
Any other questions?
Yeah, you already have the front door and the rear door. What is your expectation about the airflow reduction if you add on the front door and the rear door?
So if I heard that correctly, so I don't think the image showed it, but it's a perforated design. So that would allow airflow, but there is also, you know, the potential option for a non-perforated door as well, which we have looked at in the past if you wanted to complete containment. Did that answer the question?
Yes.
So the internal rack brace, that's for shipping stresses and shock and vibe?
Yeah, yes, it's not only, so obviously the biggest challenge with the ORV3 rack design is the equipment being non-fixed, so you've got the latches. So when those racks are in transit in the ship-loadable packaging, you can obviously, you can see some quite big stresses and impacts in trucks and other things. So to replicate that in our testing, obviously the braces is necessary to hold that. If you don't have it in there, like we showed in the presentation, you can only be at 800 kilos, or else you start to see what we call like bowing of the frame. And then when that opens, all the latches release, and then you see the equipment slide forward.
So the question is, being as a rack here is a really valuable piece of real estate sometimes, why wouldn't you have those braces external and removable? So you attach them when you ship and take them off when the rack's deployed.
Maybe you can answer that from the
I didn't hear the question.
So could you make the shipping braces removable and external to the equipment so that they only are attached when you're shipping, and then they're removed when the rack is deployed, and then reused?
Yeah, potentially that is an option that you could do on ours for our workflow when we receive the racks at our data centers. That's not how we've typically done it in the past. And I guess another thing to consider is as we're moving these racks around within the data centers, we still want to make sure that we have that cross brace in there, providing that stiffness of the frame. We've got a lot of expensive gear in our racks, and we definitely don't want to have gear delatching. Not only does it potentially introduce damage to the gear, but it potentially creates a safety hazard for the personnel moving those racks around as well. So we want to maintain that stiffness of the rack as it's deployed.
Any other questions, guys?
All right,
No, brilliant, thanks.
Yeah, I'd like to invite everyone, if you're interested in learning more about the rack, check out the wiki page. Links are here. You can scan the QR code. And there's also a link to the mailing list as well. So feel free to grab the presentation from the website and click on the links if you're interested. Thank you.
Yeah, thanks.